Good day, grade 8 learners. We are now in quarter 3, week 4 of grade 8 mathematics, and it is entitled Postulates on Triangle Congruence. In quarter 3, week 4, we have only one learning competency, and it is illustrates the SAS, ASA, and SSS congruence postulates. Now, are you ready? So let us start now to discuss the postulates on triangle congruence. And here is the necessary definition. An angle of a triangle is said to be included if its sides are sides of the triangle from the same vertex. So if we have two sides, given two sides, and the angle between them, that is what we call the included angle. Next thing that you need to know is when a side of a triangle is said to be included by angles when the vertices of the triangle are the endpoints of the segment. So we have here two angles, and the included side is the side between the two vertices. Now let us proceed in the SAS congruence postulate. SAS stands for side, angle, side. So it states that if two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the triangles are congruent. So here, given angle F and angle R are congruent, and segment FA and segment RA are also congruent, and segment AI, it bisects segment FR. Now we will prove that the triangle FAI is congruent to the triangle RAI by using SAS congruence postulate. So in proving, we will gonna use the two-column table. One column for the statements and one column for the reason. Now let us now start proving. We have segment FA is congruent to segment RA. It states in the given. Angle F is congruent to angle R. Also, it states in the given. And segment AI, it bisects the segment FR. And it is also given. And for the number 4, we have segment FI is congruent to segment RI. And its reason, the definition of bisector. Now, we already proved that triangle FAI is congruent to triangle RAI by the reason of SAS congruence postulate or side angle side congruence postulate. Now, another example for SAS congruence postulate, we have here two triangles, triangle ABE and triangle CDE. So we have here given segment AB is congruent to segment CD. Then segment AB is perpendicular to segment BD. And segment CD is perpendicular also to segment BD. And E or point E is the midpoint of segment BD. Now we will gonna prove triangle ABE is congruent to triangle CDE. So let's now start proving. So we will also use the two-column table, one column for the statement and one column for the reason. Now let's start. We have here segment AB is congruent to segment CD, and segment AB is perpendicular to segment BD. So the reason, it is given. And next is angle B is a right angle, and its reason is the definition of perpendicular lines. So perpendicular lines, it forms right angle. And we have here CD or segment CD is perpendicular to segment BD, and the reason is it is given. And angle D is a right angle. Also, definition of perpendicular lines. And we have here angle B is congruent to angle D because any two right angles are congruent. And next, E is the midpoint of segment BD because it is a given. And for number 7, we have segment BE is congruent to segment DE, and it is the definition of midpoint. Now we already proved that triangle ABE is congruent to triangle CDE by SAS congruence postulate or side angle side congruence postulate. Now let's proceed to ASA congruence postulate. ASA stands for angle side angle congruence postulate. It states that if two angles and the included side of one triangle are congruent to the corresponding angles and included side of another triangle, then the triangles are congruent. So here's an example. Given right triangles ABC and triangle PQR, those are right triangles. And with segment AB is congruent to segment PQ. And angle A is congruent to angle P. Now, using ASA congruence postulate, let us prove that triangle ABC is congruent to triangle PQR. So first, triangle ABC and triangle PQR are right triangle because it is given, and angle B is congruent to angle Q because all right triangles are congruent, and segment AB is congruent to segment PQ because it is given, and angle A is congruent to angle P, also it is given. And now, we already proved that triangle ABC is congruent to triangle PQR with ASA congruence postulate or angle side angle congruence postulate. Now another example. Let us prove that triangle ABD is congruent to triangle XYZ with a given of segment AB is congruent to segment XY, angle B is congruent to angle Y, angle D is congruent to angle Z. So first, we have segment AB is congruent to segment XY, angle B is congruent to angle Y, and angle D is congruent to angle Z, and it is given. Next is the measure of angle B is equal to the measure of angle Y, and the measure of angle D is equal to the measure of angle Z, and it is the definition of congruent angles. Next is the measure of angle B plus the measure of angle D is equal to the measure of angle Y plus the measure of angle Z, and it is the addition property of equality. Next is the measure of angle B plus the measure of angle D plus the measure of angle A, that is equal to 180 degrees, and also measure of angle Y plus the measure of angle Z plus the measure of angle X, that is also equal to 180. And the reason is the sum of the measure of the angles. Next is angle B or measure of angle B plus the measure of angle D plus the measure of angle A is equal to the measure of angle Y plus the measure of angle Z plus the measure of angle X. And it is the transitive property of equality. And next is measure of angle Y plus measure of angle Z plus the measure of angle A is equal to the measure of angle Y plus the measure of angle Z plus the measure of angle X. And it is for substitution property. And we have here the measure of angle A is equal to the measure of angle X. And that is the subtraction property of equality. Next is angle A is congruent to angle X. And it is the definition of congruent angles. Now, we already proved that triangle ABD is congruent to triangle XYZ with the ASA congruence postulate. Now let us proceed to the SSS congruence postulate, or the side-side-side congruence postulate. And it states that if three sides of one triangle are congruent to the corresponding three sides of the another triangle, then the two triangles are congruent. So we have here triangle ABC and triangle ADC. So let us prove that triangle ABC is congruent to triangle ADC with the given of segment AB is congruent to segment AD and segment BC is congruent to segment DC. So let's start proving. So first we have segment AB is congruent to segment AD with the reason of given. Next is segment BC is congruent to segment DC with the reason of given. And we have here segment AC is congruent to segment AC. It is by reflexive property. Now we already proved that triangle ABC is congruent to triangle ADC with the reason of SSS congruence postulate. Next is let's prove that triangle ABC is congruent to triangle DCB with the given of segment AB is congruent to segment DC and segment AC is congruent to segment DB. So we have here segment AB is congruent to segment DC with the reason of given, and segment AC is congruent to segment DB because it is also given, and segment BC is congruent to segment CB with the reason of reflexive property. And now we already proved that triangle ABC is congruent to triangle DCB. And that's all for the quarter 3 week 4 of grade 8 mathematics. Don't forget to subscribe and hit the notification button. Stay safe and stay sane. Goodbye everyone!